Well, aren't you hoping that I can talk better this time than before? I do. Oh my goodness. Okay, lesson 4.3, we're going to learn about congruent angles. So we've listed the content standards, if you want to pause and read that for a moment to know what's expected, and our mathematical practices. Okay, before you've identified and used congruent angles, and today we're going to name and use corresponding parts of congruent polygons, and we're going to prove triangles congruent using the definition of congruence. New vocabulary today, only 3: congruent, congruent polygons, and corresponding parts. One of my favorites. Okay, let's look at what's congruent and what's not congruent. If two geometric figures have exactly the same shape and size, they are congruent. So these are just positioned differently, but they have the exact same shape and size. Now these have the same shape, they're positioned the same way, but look at their size. So the sizes are all different, so they are not congruent. If in two congruent polygons, all of the parts of one polygon are congruent to the corresponding parts or matching parts of the other polygon, these corresponding parts include corresponding angles and corresponding sides. Other congruent statements for the triangles exist. Valid congruent statements for congruent polygons list corresponding vertices in the same order. It is important that you keep them in the same order. So if we're looking at triangle ABC, and this is important when you're naming a congruent statement. So you list all the corresponding angles, and notice this equal sign with the tilde over it, that means congruent. So you list all the corresponding angles, all the corresponding sides. Then the congruent statement, notice these triangles are flipped, right? But see the 2 hash marks on A, and there's 2 hash marks on H? They were nice enough to label them in the same color. B has 1. J has 1. Both of them are light blue. C has 3. So it matches with K, which has 3. So when you're naming it, if you start with A on 1 and go A, B, C, red, blue, green, you have to go red, blue, green and name in this same order. That's extremely important because A, B, C is not congruent to H, K, J. So that's what I'm showing you here, is that the colors have to correspond. Here is blue, green, red, blue, green, red. That's a valid statement. Red, blue, green, red, green, blue. So this is not a valid statement. So you have to list them in the right order. So now we're going to list all the sides and angles that are congruent. So the angles that are congruent are listed, and I'll let you pause for a moment and read those. You don't need me to read that to you. And then the sides are listed. Notice when we list angles, we use the angle notation. And when we list sides, we show that they're segments. That's extremely important. You just can't say AB's congruent to RT. I need to see segment, and I need to see angle. So all corresponding parts of the 2 polygons are congruent, which we're told that. We're going to identify them to show that they're congruent. Therefore, ABCD is congruent to RTPSQ. So if we list A first on one side, we have to list R first on the next side. Notice that. Okay, time to check your progress. So pause for a moment and read, and then you can come back and check your answer. Did you find segment AC is congruent to segment DF? Very good. The phrase if and only if in the congruent polygon definition means that both the conditional and its converse are true. So if if 2 polygons are congruent, then their corresponding parts are congruent. So for triangles, we say that corresponding parts of congruent triangles are congruent, or we just call it CPCTC. Here, corresponding parts of congruent triangles are congruent. C, P, C, T, C. And instead of writing all of this out, corresponding parts of congruent triangles are congruent, I'll use CPCTC as my statement. or my reason. So looking in the diagram below, triangle ITP is congruent to triangle NGO. Does that make you want to sing BINGO? Just did me. Sorry about that. Okay, we're defining the values of X and Y. So angle O is congruent to angle P. Okay, by CPC/TC. Corresponding parts of congruent triangles are congruent. So that means the measurement of angle O is equal to the measurement of angle P by the definition of congruence. So 6y minus 14 is equal to 40. If you haven't already done so, you might want to take a minute to draw this figure because we're going to lose it probably. Yep, we did. 6y equals 54. So we divide both sides by 6. So y is equal to 9. Segment NG is congruent to segment IT, so NG is equal to IT by definition of congruence. We can substitute in, simplify, and so X is equal to 25.5. Okay, so we solve for X and Y. Time for you to check your progress. So take a moment, study the diagram, then come back and check your answer. I did get answer A. I set 2y minus 3 is equal to 2.5 and then solve for y. And 6x plus 8 is equal to 35 and solve for x. And so I did get the answer A as well. Okay, now we're going to prove triangles congruent. The triangle angle sum theorem you learned in lesson 4.2 leads to another theorem about the angles in two triangles. That would be the third angles theorem. The third angles theorem says if two angles of one triangle are congruent to two angles in the second triangle, then the third angles are congruent. Doesn't that make sense? So we've got a drawing of a tower's roof, and they said it's composed of congruent angles, all converging at a top angle. So every one of these angles are congruent, they tell us. So if IJK is congruent to IKJ and the measurement of IJK is 72, find JIH. Okay. So these two triangles are congruent, JIK and JIH. All the angles added together are equal to 180. We know that by the triangle angle sum theorem. So we can substitute in the measures and find that the measure of JIK is 36. And from the third angles theorem, then we know that JIH is also 36. Okay, check your progress. This one took me a little bit. I needed to draw it out on my paper so I could see it better. So pause for a moment, take time to draw the figure and label what it is you know, and then come back and check your answer. I did get 85 because triangle KLM is congruent to triangle NJL. So angle KLM is congruent to angle KML. And the measurement of angle KML is 47.5. So I did 47.5 plus 47.5 plus x equals 180. So 95 plus x equals 180, so x is equal to 85. Now we're going to prove that two triangles are congruent, writing a two-column proof. So this is what we're given. And you might draw this figure and write down what's given and what we are to prove. So pause the video for a moment and do that before we go on. Well, it's a good thing you wrote down the given and the proof because now we've lost it. So we're going to fill in our two-column proof. First of all, we're writing in our given using the vertical angles theorem. We know those two are congruent. Third angles theorem, then, we know that angle M is congruent to angle O. So we can say that triangle LMN is congruent to triangle PON by corresponding parts of congruent triangles are congruent. That wasn't too bad, was it? Okay, time for you to check your progress. So find the missing information in the following proof. That's what we're looking for, the reason to number 4. So here are your choices: CPCTC, vertical angles theorem, third angles theorem, or definition of congruent angles. It is the third angles theorem. Very good. Like congruence of segments and angles, congruence of triangles is reflexive, symmetric, and transitive. So we can use properties of triangle congruence. You might want to take a note of that and place that in your notes as well. Okay, you are ready to begin the lesson.